Okay, so we're going to talk about square and cube roots today. So a square root is a number that multiplies by itself to get another number. We are essentially looking for the original number and not the number, the answer to the product. So a radical sign is actually the sign that we use to figure out or to show that we want to find the square root or the cube root. So it's a symbol used to show that we want to find the root. So we have some different options that we can be looking at. There are three of them actually that we're going to be seeing today and in the future. So one of them is just the sign without any kind of symbol in front of it. So what this means is the positive root. If we have the negative sign out front, that means the negative root. And if I have this plus and minus sign in front of it, that means I'm looking for both roots. So this would be positive and negative. So let's look at some examples here. So example 1, letter A, we have square root of 64. So these are some roots that you should be able to memorize and be able to know for when we take our quiz and our final, I guess, coming up soon. So the square root of 64, we're looking for, there's no symbol in front of it, so we're looking for what positive number times itself is 64. And that number is 8. You don't have to show that it's 8 squared because what this is showing you is what times itself is 64. That'd be 8. Letter B, there's a negative symbol in front of this radical sign, so I'm looking for the negative root of 121. So the positive root is 11, so the negative root would be negative 11. Again, that's one that you should be able to memorize. Letter C, I have both positive and negative, which means I'm going to be looking for both roots. So there's a couple of different ways that I can show this. I can either show it as 16 and negative 16, or I can simply show plus and minus 16. Both are perfectly great. Both are acceptable. In fact, both would be accepted on the final. But you get to choose which one you want to do. Now, letter D. This is an interesting one because it's looking for the square root of negative 9. And there isn't a number multiplied by itself that'll get me a negative number. So if we think back to our integer rules, if I multiply a positive and a positive, my answer will be positive. If I multiply a negative and a negative together, my answer will also be positive. The only way that I can get a negative is if I do positive times negative. And these two aren't the same. Which means that letter D would be no real answer. As you progress getting higher and higher in math, you will actually see that this one is possible, but not with the information that we have right now. It's not a real answer. So example 2, it says to estimate each square root to the nearest integer. So one way that we can look at it is by making a number line. And if I use my perfect squares, I would know that it's 1, 4, 9, 16, 25. And that's all I have to do because I'm looking between 16 and 25. So I have 1, 4, 9, 16, 25. These are not to scale. I'm simply showing you that these are these perfect squares. So 22 is somewhere here. This is where 22 is. 22 is closer to 25 than it is to 16. So the square root of 22 is about equal to 5. And the reason why is because it's closer to the square root of 25 than it is to the square root of 16. Because 22 is closer to 25 than it is to 16. All right, and then letter B here. So we're looking for the negative root. So again, we're going to be looking at numbers that are going to be between, where 319 kind of fits between. So we have 17 squared, which is going to be 289. And we have 18 squared, which is 324. Oh, these numbers should be switched around. So 319 is significantly closer to 324 than it is to 289. So because 289 is 17 squared and 324 is 18 squared, which means that the negative square root of 319 is about negative 18. And the reason why is because 319 is closer to 324 than to 289. 324 is 18 squared, where 289 is 17 squared. So the estimate for the square root of 319 is 18. It's asking for the negative square root, so we'd be looking at negative 18. All right, on the back side, we're going to be looking at cube roots. This is the second part of this lesson here. So cube roots, same as square roots. The only difference is in a cube root, we're looking for what number multiplied 3 times. Equals a number. So the radical sign, very, very similar. The only difference is I have a 3 written right here, and this means the cube root. Now, when we're looking at cube roots, you cannot have a positive or a negative root. The reason why is because if I have positive times positive times positive, I'm going to get a positive number. If I have negative times negative times negative, that equals a negative number. So the only possible answer could be positive, negative, or 0. You can't have a positive and negative cube root. And the reason why, again, is because 3 times, or a number multiplied 3 times together will always be the same sign as the number that is multiplied together. So, which means the cube root of a positive number is going to be positive. The cube root of a negative number is going to be negative. And of course, the cube root of 0 is just going to be 0. So let's look at letters A and B. These are going to be numbers that you should be memorizing. But if I look at the cube root of 125, first of all, 125, that is a negative or a positive number underneath that radical sign, which means that my root will be positive. And I know that we've done this number in the past, but the cube root of 125 is 5. And if we check that, we have 5 times 5 times 5. 5 times 5 is 25. And then 5 times 25 is 125, which is what I had originally. So the cube root of 125 is 5. Now, this next one here, the cube root of negative 2,197, this is one that's going to be not nearly as well known, but it can still be done easily. In fact, we've already done this one way back in lesson 1 or 2 when we were talking about rewriting numbers to different powers. 2197 is 13 raised to the third power. Now, because the number underneath the radical sign, which is called the radicand, actually, is negative, my root is negative. And if I were to go and check this, negative 13 times negative 13 is going to get me 169. And then times negative 13 again is 2,197. It would be negative. Example 4, estimate the cube root of 47 to the nearest integer. We're going to use the same modeling technique as we did last time. The only difference is, instead of writing the perfect squares, we're going to write the perfect cubes. So we have 1, we have 8, we have 64. I need significantly more space here. Oh, I'm sorry, 27, and then 64. 47 is kind of right in the middle here. 47 kind of fits right in between 27 and 64. So, which one is it? Well, let's figure out which one 47 is closer to, 27 or 64. So, the distance between 47 and 27 is 20. The distance between 47 and 64 is 17. Which means that we're really, really close to this 64. Again, 1, the cube root of this would be 1. The cube root of 8 is 2. The cube root of 27 is 3. The cube root of 64 is 4. Which means that because 47 is closer to 64, the cube root of 47 is about 4. In fact, the actual answer is 3.61, and that's very close to both 3 and 4. But since 47 is closer to 64 than it is to 27, the approximation for the cube root of 47 is about 4. Now, example 5, this is where we might run into some issues here, because it's not asking you for the square root of 81. It's asking you what times itself, or what squared, is 81. And that's two very different questions. So here, what times itself is 81? Well, I know that the square root of 81 is 9. But I also know that if I have a square root, I could also have a positive or negative answer. So it's 9 and negative 9. And I can check that by going 9 squared, or 9 times 9 is 81. And negative 9 squared, or negative 9 times negative 9 is also 81. Remember, when you're plugging this into your calculator, it needs to look like this in your calculator. Or it could look like this. But this negative 9, this is the base. That needs to be in parentheses. And last but not least, letter B, p cubed equals 64. We're going to be looking at what number times itself 3 times is 64. We kind of talked about it in the previous example, but 64 is 4 times 4 times 4. Now, because 64 is positive, my root also has to be positive. And it cannot be negative, because if I multiply negative 4 together 3 times, I would get negative 64. So in this case, p is exactly equal to 4. It cannot be negative, it cannot be 0, it has to be 4. If you have any questions, please let me know. Otherwise, this is the end of Lesson 6, Square and Cube Roots.